All right, so a system of linear inequalities is a set of two or more linear inequalities in the same variable. Again, the only way to solve it is by graphing. Because think about inequalities, linear inequalities. Isn't there tons and tons of points that make that inequality true? Yes, because that's the reason why we shade to represent all of those solutions for it. So the solution to that system of linear inequalities is an ordered pair. My lines didn't show up. Is an ordered pair that is the solution to each of the inequalities. So again, if I have a point, it has to be true for both of those inequalities, right? Not just one, but both of them. It has to be in both shaded regions. Yeah, which we'll get down here for that. All right, so looking at this, just tell whether an ordered pair is the solution to the system. So does 3, 5, is that a solution to both of these inequalities? So would it fall within the shaded regions of both of those inequalities? And besides graphing, if I don't want to graph, how could I tell if an ordered pair is a solution to both of those? Just plug it in, okay? So if I'm looking at that first one, what is the y coordinate? 5 is less than 2 times, what's my x? 3. What's 2 times 3? 6. Is 5 less than 6? Yes. So can I automatically say yes, it's a solution? No, because I have to check the second one still, right? Okay. So it's not just the point of intersection, it's does it lie in the shaded region as well? Okay. So let's look at the next one. What's my y coordinate? 5. Is that greater than or equal to, what's my x? 3. And what's 3 plus 1? 4. Is 5 greater than or equal to 4? Yes, it is. So is 3, 5 a solution to this system? Yes, it is. Yes, it is. All right. What about B? Try B. Let's look at that first equation. What's my y coordinate? 0. Is that less than 2 times, what's my x coordinate? 2. 0. Is 0 less than, what's 2 times negative 2? Negative 4. And is 0 less than negative 4? No. So could negative 2, 0 be a solution to the system? No. And do I even have to check the other inequality? No, because we already said no for the first one. We don't have to plug it into the second one. Okay, it has to be true for both. All right, go ahead and do 2. Is 1, 4 and negative 2, 4 a solution to this inequality? So let's look at that first one. All right, what is my y coordinate for that first point? 4, and what's my x? 1. All right, so is 4 greater than or equal to, what's 3 times 1? 3, and then 3 plus 1 is 4. Is 4 greater than or equal to 4? Yes, it is. So it works for that one. Let's try the next one. Y, is that greater than x minus 1? And what's my y? 4. And what's my x? 1. So is 4 greater than, what's 1 minus 1? 0. Is 4 greater than 0? Yes, it is. So is this a solution? Yes, it is. All right, what about B? Let's try the first one again. Is y greater than or equal to 3 times x plus 1. What is my y? 4. And what is my x? All right, so is 4 greater than or equal to, what's 3 times negative 2? And negative 6 plus 1? Negative 5. So is 4 greater than or equal to negative 5? Yes. Let's check the other one. So is y greater than x minus 1? And what's my y? 4. And what's my x? Is 4 greater than, what's negative 2 minus 1? Is 4 greater than negative 3? Yes. So is this also a solution? Yes, it is. Is 0, 0 a solution to that last one? No, why not? Right, 0 is not greater than or equal to 1. But, all right, now again, let's solve these. So how do we actually figure out what points are solutions, okay? The only way, again, is by graphing. So there's no substitution, there's no elimination, because there's multiple solutions for every single one of these systems, right? Because they're inequalities, there's not just one answer, there's multiple answers, right? Okay. So first thing, we're going to shade, or we're going to graph each inequality on the same coordinate plane. Okay. And when we graph that, we have to include, is it a dotted or solid? And do we shade what? Above or below? You have to answer those and do it for every single one of your lines. Okay. Then, once you do that, can you find the intersection? And what's intersection mean? Of the shading. Okay, the intersection of the shading means where you have the double shading, where they overlap. Shading overlaps. Overlaps. Shading overlaps. Guess what? That intersection, okay, the intersection is the solution to that. So either darken up, or you can circle it, something, and I'll show you how. If you have highlighters, tell me where the color changes with it. Okay, that's why I like the highlighters in that sense. Actually, I'm gonna go grab some. Okay, let's look over. All right, so real quick, I want you guys to tell me my slope and the y-intercept for both of these first, before you graph them. And I'm gonna go grab my highlighters. So with y is less than or equal to 3, what is my slope? 0. So 0 over 1, right? And what's my y-intercept? 3. So I'm going to start at 3, and I'm going to rise 0, but run 1. So what kind of line do we have here? We're going to have a horizontal line, right? Okay. Now, is this, my inequality sign is less than or equal to? So is it going to be a dotted or solid? It's going to be a solid line. And then which way would I shade, above or below that? So it's less than, so am I going to shade above or below? Below. So I'm going to shade all the points below that. So the yellow is the solution to my horizontal line. You guys okay with that? All right. Now let's look at y is greater than x plus 2. What is my slope for that one? One over 1, and what's my y-intercept? 2, right? So I'm going to start at 2, and then I'm going to do what? Up 1 and to the right 1. So up 1, right 1, up 1, right 1, up 1, right 1, or down 1. Okay. Is this going to be dotted or solid? So my inequality is a greater than. So dotted or solid? Dotted. I'm going to draw a dotted line through those points. And then am I going to shade above or below that? Above. So above the line, if this is at 2, would be like 3, 4, 5, 6. So I need to shade this side of my second line. Obviously, I kind of went out of the thing. Now, do you guys see where your intersection is? Yes. So my solution, and this is what I'm saying, either darken it up or make a point. My solution is this area right here, right? Why? Because that's where the color changes. That's where that intersection was. So any point that falls within this region would be a solution to both of those lines. Okay, does that make sense to you? And if you don't have highlighters, if you use pencil, if you just go really lightly, you'll be able to see the overlap too. Okay. All right, let's look at number 2, since one of them's already in slope-intercept form. All right, so let's look at this first one. What is the slope of my first one? -1 over 1, and my y-intercept is 4. You guys okay with that? Okay. So now I'm going to start at a +4, and then what would I do? Go down 1 and to the right 1. So down 1, right 1, down 1, right 1, and so on. Now, what's my inequality sign? Greater than or equal to. So is that going to be a dotted or solid? Solid line. And which way do I shade, above or below it? Above, because it's greater. So if I'm looking at 4, 5, 6, 7, 8 would be above. So I'm going to shade on the right side of my line. Is everyone okay with that? Okay. Let's look at the second one. What is wrong with the second equation there? We're not in slope-intercept form, so how would I move the x over? I would subtract it. So I get y is less than or equal to -x plus 0. I don't need the plus 0, but I'm going to put it there. It doesn't matter. Okay. And I didn't flip my inequality sign because did I divide by a negative? No. All right. So what is my slope for this one? -1 over 1, and my y-intercept is 0. So what do we know about these lines automatically? They're parallel. This here, if it was parallel, okay, if it was an equation, we would say no solution, right? But because we're shading, we might have actually a solution and overlapping of these, okay? So let's keep going with this. Is this going to be a dotted or solid line? Solid. And which way do I shade this one? Below, right? So if I'm at 0, -1, -2, so this side would be my solution. Now, in this case, there is no solution. Why? There's no overlap in this. So this one is a no solution. But will they always be no solution? No. No. Okay. What if I shaded the purple line where the blue shading is? If I shaded above it, where would my intersection be? If I shaded above this one instead of below, it'd be just where this yellow is, right? Yeah. If I shaded below this one, below the orange, my shaded would be the blue, right? My solution. What if I shaded above and below? So above the purple, below the orange. It'd be exactly in between the two. Yeah. So there's multiple ways we can do that. All right, let's look at 4. Okay. Are both in y equals mx plus b. That's nice. So what's my slope for the first one? 2 over 1, and my y-intercept is 3. So I'm going to start at -3. And then what would I do? Up 2 and to the right 1. Up 2, right 1. Up 2, right 1. All right, let's look at my inequality sign. We have a greater than. So will that be a dotted or dashed? It's going to be a dashed. Why? Because it's not equal to, right? And do I shade above or below this one? Above, right? So where would it be above? Kind of to the left or to the right of that? Right? So if I'm at -3, above would be like towards the 0, right? I know I'm on this side of my line. You get a color in there. All right, let's look at the second one. What's my slope of the second line? 1/2. And what's my y-intercept? 1. So I'm going to start at what? 1, and then do what? Up 1 and to the right 2. So from here, up 1, right 2, up 1, right 2, up 1, right 2. Or I could go down and to the left. Now, is that one going to be, let's look at our inequality sign. So it's greater than or equal to, dotted or solid? Solid. All right, and now, would I shade above or below this one? Above. Do you guys have an idea where your solution is going to be? Yeah. All right, so if this is the purple line, above would be this way. So all of this is the solution to that line, but what would be the solution to this system? Where do you guys see your intersection? In this spot right here, right? So this here is my solution. There we go. So make sure it's darker, or, you know, if you're using highlighters, it changes color. So make sure you just kind of show that the green is the color or whatever it is. Okay. Okay, 3. What's wrong with these? Huh? Number 3? I haven't even graphed them yet. But what do I have to do first? That's okay. Oh, you already know. What? They're not y equals mx plus b. What else do you guys notice about them before we put them in there? They're going to be parallel. Why? Aren't my x's and the y's the exact same? Yeah. So these are going to be parallel. We can't automatically say no solution though, can we? No. All right. So how do I move 2x over on both of these? When I subtract it? So y. Oh, great. That's a greater than. Ooh, that's an ugly greater than. -2x plus 2. All right. All right. Let's look at that first line. What is my slope for the first one, the top one? -2 over 1, and my y-intercept is -1. So I'm going to start at -1, and then my rise is negative, so I'm going to go down 2, and my run is positive, so right 1. So down 2, right 1, down 2, right 1, or up 2 and to the left. Now, what's my inequality sign there? Say less than, right? Less than. Dotted or solid? Dotted. And which way do I shade, above or below that? It's less, so below, right? So if I'm at -1, below would be -2, -4, -5, all of that. So we know we have to be on this side of mine. You guys okay with that? All right. Now, the next one. What's my slope of the second one? As we said, they're parallel, so it's going to be -2/1 again. But what's my y-intercept here? 3. Now I'm going to start at 3 and go down to right 1. Inequality signs greater than, dotted or solid? Dotted. And which way do I shade on that one? Which way do I shade on this one? Above it, right? So what do you guys notice? This one's no solution again. I forgot I needed to change one of these, but that's all right. So it's no solution. But if we needed to, if we did shade below it, would you guys be able to find where the intersection is? Yeah. Anything, yep. All right, any questions with solving systems? Was that bad? No, it's just the shading, right? Just remembering the shading. Now, example 3 here is writing the system from that. I need to highlight this one for a second so you guys can see it a little better. Do you guys know how to write equations from a graph? I think so, right? Do you know how to put equations in y = mx + b form? Yeah. Do you know how to, and I think the shape is there. Now, the only difference is we have inequality symbols. So can we figure out if it's going to be a less than, a greater than, all of that? Yes. All right, let's go ahead and do this dotted line first, okay? So we're going to put it in y = mx + b form, which I'm not going to worry about the inequality sign yet. Okay. So this dotted line, where does it cross the y-axis? At 0. So this would be like +0, right? Which I'll simplify it a little bit here in a second. Now, our slope, we need to find 2 points that lie on that line, right? To find my slope. First off, is my slope going to be positive or negative? It's going to be positive because we know that line's going up, right? Okay. So I have 0, 0. Doesn't 1, 1 lie on that as well? Yeah, I think so. So what would be my slope if I have 0, 0, and 1, 1? How much do I rise? 1, and I run 1. So I have 1/1, right? Which I'll simplify this here in a second. Now, is this dotted or solid line? This is a dotted line. So will I include the equal to? No. So it's just going to be a less than or a greater than symbol. And is this yellow shaded above or below my line? It's below. So would that be a greater than or a less than? Less than. So this simplified would be y is less than x. You guys okay with that? All right. Now, looking at this horizontal line, if we have a horizontal line, again, we're y because we crossed the y-axis. What is the slope of a horizontal line? How much do we rise? How much do we rise? 0, and we run what? 1. So 0/1 is just 0. And what's 0 times x? 0, it's gone, isn't it? Let's find my y-intercept. Where does this cross the y-axis? At -2. So this cancels, so we have y, we have -2. Now we got to look at the inequality sign. Is it a dotted or solid? Solid. So that means we will have the equal to, right? And am I shaded above it or below it? Above. So is that less than or greater than? Greater than. So there's your equation for those lines. Not too bad, huh? All right, let's look at this one again. Okay, let's pick that one. Now let's do our inequality sign actually first this time. Do I shade above or below that? Above, so we know it's going to be a greater than. Is it dotted or solid? Dotted, so will it be greater than or equal to? Just greater than, yeah. All right, now let's find our slope. So, or let's find my y-intercept. Where does this line cross the y-axis? Right here. And where is that? -1. And now is my slope going to be positive or negative? Positive. Positive, right? So let's go ahead and find another point on here. How about this one? This point works, right? Where they intersect. So how much do I rise here? 1, 2, and I run 1, 2, 3. So my slope would be 2 over 3. I don't have to simplify that one at all, do I? No. All right. Now, looking at the vertical line's different, isn't it? The vertical line only passes through what axis? The X, right? It does not pass through the Y. So guess what? This one actually starts with X, not the Y, because there's no slope with it, right? Vertical lines have no slope. They're undefined. Now, where does that cross the X-axis? At 3. Now, is it dotted or solid? Solid, so we know it's equal to. Now, there's not an above and a below the line. But let's think about this. Which way is shaded from this? Numbers that are greater than 3 or less than 3? Less than 3. So X is less than or equal to 3. And there you go. And you just wrote your inequalities.